In this video, we will do some examples involving double sums. So double the sigmas. So let's look at an example. Let's say I want to evaluate the sum from I equals 1 to 5. And then inside of it, I have the sum from j equals 1 to I of I plus j. So to break this down, let's start by looking at this outer sum. So I have the sum from I equals 1 to 5. So it starts with the value when I equals 1. And if I were to let I be equal to 1, what the inside part of that becomes is it becomes the sum from j equals 1. And then I get to plug in I equals 1 where the I is up there. So I get to write 1 there. And then in the parentheses now, my value for I is 1. And then I get plus j. So that's what I get if you let I be equal to 1. All right, well then what if I is equal to 2? So this is if I equals 1. What if I equals 2? Well, the inside part of that outer sum would now be the sum from j equals 1 to 2, because I'm plugging in 2 where the I is. And then parentheses, I'll plug in the 2 for the I, and I'll get 2 plus j. All right, so I get this first sum when I equals 1. This second sum when I equals 2. So I'm going to be starting to sum these together. Okay, so I'm going to keep going like this. I'm going to keep going like this until finally I plug in I equals 5. All right, finally when I plug in I equals 5, and that'll give me the sum from j equals 1. And then I plug in 5 where the I is. In the parentheses, same thing. Plug in 5 for the I. And then I'll get plus j. Okay, so in essence, for each one of these values we plug in for I, the inside part of this sum becomes another sum in and of itself. So we just got to work out there are 5 sums here for us to work out. Okay, so let me organize some of this work into each of these cases. So I have I equals 1. When I equals 1, well, I'm just going to be plugging 1 in for j. There's no other terms because the term up top is 1. So overall, there's just one term in this sum, which is just going to be, if I plug in 1 for j, I get 2. And that's it. What about when I equals 2? When I equals 2, I'll start off by plugging 1 in for j, which gives me 3. And then I'll plug in 2 for j, which gives me 4. And that's when I stop, because now I've reached this number up top. Okay, cool. And if I do the same thing for I equals 3, which I don't have written down, but the I equals 3 part in the parentheses would have had a 3 plus j. It would have had that. And if I start off by plugging in 1 for j, what I would get is 4. And then I would plug in 2 to get 5. And then I would plug in 3 to get 6. Okay, and if I continue down this pattern, for I equals 4, what I would get is 5 plus 6 plus 7 plus 8. And then finally, when I equals 5, if I plug j equals 1 into this, I get 6 first, plus 7 plus 8 plus 9 plus 10. Because when I plug in the number up top, I get 10. So overall, I have to add all of these numbers together. So I got to take all of this, sum them all together. So summing these, we get, kind of just have to add them together. But if we do that, we get 90. And that's it. Okay, all right, let's do another one of these. So let's find a closed formula for the sum from j equals 1 to n of the sum from I equals 1 to j of 5j. So first, I want to give you a chance to try this. So I want to have you pause the video for 3 minutes to try this. So pause it in 4, 3, 2, 1. Pause it for 3 minutes to try this. All right, so hopefully you did that. Hopefully you paused this and tried it. So let's talk about it. So for this one, before I start, thinking about the outer sum and doing it case by case like I had before, I noticed that this time it doesn't just go from like j equals 1 to a specific number. It goes until n. So, and I'm going to find a closed formula for this. So I'm going to need to evaluate some of these sums using maybe my summation formulas that I've seen before. So maybe let me look at the sum that I have inside and see if I can get a handle on this. Well, it says start by plugging in 1 for I, but there's no I in this. Like, it's a different variable, j. So when I try to plug in 1 for I, what I end up getting when I plug in 1 for I is, well, I just get 5j because there's no i's to plug into. And then I plug in 2 for I. But when I do that, I still get 5j because there's no I to plug into. And I keep doing that, and each time I plug in a different value of I still just get 5j each time. So how many terms are there? Well, I started by plugging in 1 for I until I reach j. So that means there are j terms here. So we're adding 5j plus j times. So this will end up equaling the outer sum from 1 to n. And this inner portion, this inner sum, just becomes the 5j that we kept adding to itself. Well, j times means multiply it by j. So it's 5j times j. Okay, so I can simplify this. I got the sum from j equals 1 to n of 5j squared. And now we've seen a sigma notation property that says if we have a constant multiplying the rest of my function here, I can pull it out in front of this the sigma. So that'll give me the 5 in front times j equals 1 to n of j squared. And we've seen a formula for this. This is the sum of 1 squared plus 2 squared up until n squared. We've seen that in a previous video. That was this whole fraction. So if we use that formula, what we end up getting is that this is 5 times, and then we get n times n plus 1 times 2n plus 1, that whole thing, over 6. And we got it. We got our closed formula.